Hi ladies. Now this time we're going to have a table of values and it's not going to start at x equals 0. So we're not going to have immediately the y-intercept, but we'll be able to figure it out in any case. Suppose we have this table of values and we want to put it in a line of slope-intercept form. So you can imagine this is like case equals 1, case equals 2, case equals 3, but we're not given case 0. But I bet we can find it. Instead of finding the y-intercept first, it's actually going to be easier to find the slope. That's because we don't have a point at x equals 0. Okay, to find the slope, it's rise over run. So I want to see for every one case that I move up, how much do I rise? So to go from 1 to 2, I run 1, and I also rise 1. To go from 2 to 3, I run 1, and I also rise 1. So that tells me my slope is 1. Knowing that, I can work backwards and find my y-intercept. So let's complete the pattern backwards. If going from 2 to 1, I go backwards 1, well at 0, I go backwards 1 from 2. I have a 0.01, which tells me my y-intercept is 1. Which means my equation must be x plus 1. Y equals x plus 1. Like that. Okay, let's find a harder problem. Okay, for this one, x is going up by 1 each time, but y is going up by 3 each time. At this point, you might be familiar enough to just say, well, if it goes up by 3 and x is only going up by 1, that means my slope is 3, and you'd be correct. Then you just have to work backwards to figure out what's the value at case 0. Well, if I just move backwards 1, it means I subtract 3, so my y-intercept must also be 3. So my equation is y equals 3x, because 3 is my slope. Caps lock is on, 3x plus 3, like that. And that's how you do those problems. More coming for level 3.